I'm going to keep recording now, so we are good. Perfect. So here we are, week 11, and this is going to be the last lecture, the last information that I'm going to ask you to utilize there for the test, okay? And some of it's going to seem a bit strange. A lot of it is going to seem familiar, which is what I want, okay? Because we've covered about half of this. And next week, there is no lecture, okay? But we'll have class, we'll have a review. And I'll set it up where I'm in front of a whiteboard. I'm going to try and set it all up so that if you guys have questions there, your assignment, and all these kinds of things. Hit me with questions. That's what we're looking for, okay? And I'll have a whole bunch of questions in the a library or kind of a review that we'll do, and you guys will be just fine. Everything should be all good. So here we go. Today we're going to be doing the normal distribution and applications of this normal distribution. Okay. We've already done these. Their review. We're going to go over them again. Okay, just to clarify, just to get everything going, right? So we're going to identify a distribution as symmetrical or skewed. Okay, we've kind of done that already, right? You've got left skew, you've got right skewed. Okay, if your mean is bigger than your median, these kinds of things. But where we're going now is we are just doing the bell-shaped. That's where we're headed right now. We're going to identify the properties of a normal distribution, and there are two that are common to all of them. And by the end of today, you'll be able to actually compare apples and oranges. Wow. Didn't think you could, eh? Number 3 here, we're going to find the area under the standard normal distribution using something called a z-score. Okay? And these are all has to dealing with finding the probabilities. Okay, so that's what we've been doing there for the assignment 2, last week's lecture, okay, which I'll go over assignment 2 after we're done this, okay, so please stick around or fast forward, however you like. There are many continuous variables, okay, but what we're talking about here is we're going to be talking about this bell-shaped, okay, this normally distributed, okay, and the bell-shaped, also called a Gaussian distribution, okay, and there are a couple of things there that you should know. We've gone through these already, and you can see here that this is one of the formulas there involved in this. Don't worry, we're not even going to go near this, okay, but where we're going here is completely scientific. It's completely sound. This is good scientific application of mathematics. And it's interesting there. And real life situations as best we can. Okay? But again, don't worry about that. That's pretty ugly. The shape and position of the normal distribution curve depends on 2 parameters. Okay? Each of these bells, as we'll call them, okay, they have a mean and a standard deviation. And you'll remember there that the standard deviation is talking about the spread of the data. Ideally, we want the smallest standard deviation possible, because that means that all of our data points are around a mean. So that means that everybody here is kind of thinking the same thing. If that's the way life was, science would be easy, wouldn't it? So, but as with curves, you'll get different standard deviations, different spread of data. Okay? So the 2 things we're going to focus on is the mean and the standard deviation. Okay? Each normally distributed variable has its own normal distribution curve, and you'll see here, like the blue one here is curve 1, and the brown one here is curve 2. You'll see there that they both have the same mean, but you'll see there that curve 1, the blue one, has kind of a bigger standard deviation, right? The brown one here, its standard deviation is tighter together. It's meaningful, Okay, and have a look at these two here. Okay, so different means, and here this is just the population symbol for mean. Okay, just the mean. That's just the way the slide is here. Okay, so this is the mean 1. This is mean 2. You see they have two different means, but you'll see there that their standard deviations are exactly the same. The same spread, right? And if you have a look at these two here, they have different means and they have different spreads, different standard deviation. So you're looking at this, and how do I compare these things? Because they're different scales. Like this is a maybe 800, maybe this is 8.5, different scale. How do I even compare these? Well, you have to standardize them. Again, bell-shaped. The mean, median, mode are equal in theory, and they're all located at the center of the distribution. These bell-shaped or Gaussian bells here, they are unimodal. Okay, curve is symmetrical about the mean. Okay, and the interesting things to note here, the curve is continuous. There are no gaps in this. Okay, at all. For every x value, there's a y value, right? There's the point for them all. Interesting, though, that you'll see there that as the line goes down, it never, ever, ever touches the x-axis. Okay? It's what we call an asymptote. It just keeps going along there. Okay? So that's how these guys get worked here. And you guys have seen this there. Oh, hello. Hi, Melissa.
Hi.
Talk to me. What? You got a question? Great.
Yeah, I'm just wondering how come it doesn't ever touch the x-axis?
That's just, it's what we call, it's an asymptote. And you'll get them there. There are some graphs that do that. They'll just snake along the line, and that's just how it goes. For our purposes, we are only going to be dealing with stuff in here. Like the asymptote there, it's a hypothetical line there that just goes along, and it just encompasses all of the possible outliers that are out there. Now, does that mean that the data goes on forever? No. It just in theory it goes along and snakes along forever. But really, all we're dealing with is this one right here. Everything you've seen on the test 2, that's all we're going to be dealing with there for this one. So good question. Yeah, that's all right. So what we've got here now, you guys have seen this. You guys were tested on it. Okay, and this is kind of what I was looking for there for the graph there for the test 2. Some people put 68%. Full marks. Okay, some people put 13.59, some people put in 95%, some people put, you know what I mean? I was pretty easy. As long as you gave me, broke this all up and away we go. That's what I was looking for, okay? But what I want you guys to understand, though, is that this graph actually means what we're looking for. The whole point of this is to find the probability of choosing an apple out of this pile, or a person, or whatever. And because that's what we're doing here. And it's the area under the curve that represents these percentages. And these percentages represent probability, which we covered there last week. Okay? Probability is equal to the number of desired divided by the total. Well, if I'm looking to choose somebody just from this group here within the first positive standard deviation, there's a 34.13 chance that I will choose somebody from here out of the whole thing. So it's the area under the curve. And where we're going today, it's going to be kind of cool. We're going to thrust you guys right into higher level statistics, because ultimately the goal of this course is for you to pick up a nursing journal article or a firefighting health report, and you're going to see statistics in there, and you're going to be all over that like a duck on a June bug, as my grandmother would say. Okay? Well, let us go. So up until here, this kind of review. And I think everything here has kind of looked familiar. I hope it does. And if it doesn't, email me. Because quiz 3, test 3 is all going to be on this. Okay? So, the standard normal distribution. Okay? The whole point of this is so that we can compare apples and oranges. Now you remember there's two aspects to each of these bell curves that are, this bell curve has these two, this bell curve has these two characteristics, and that bell curve has the same two. Now exactly the same numbers? No. But all of these bell curves have a mean. Right? Okay, so we have a starting point for all of these guys. Right? And all of them have a standard deviation. Within the first standard deviation, you have 68%. Within the second standard deviation, you have 95%. Within the third standard deviation, you have 99.7%. Right? They all have these. Now, they might be different numbers, but they all have these. So now what we can do is we transform these, and that's what we're going to do. So this is similar to a normal distribution. Here we're talking about standardizing. Okay? Except that the total area under the curve is 1. Now going back to this, the total area under the curve is 100%, but we've talked about this there, that 1 is also equal to 100%. Okay, 34.13% we would write as a decimal, 0.3413, right? So the total area under a curve is 100%. And the area under the curve for a particular range is equal to the probability of that happening. That's all it is. The area under the curve is your probability. Now, let's have a look here. Comparing apples and oranges. What am I talking about here? And the two commonalities that all distributions have is they have the same shape. Okay? They have this bell shaped with a certain standard deviation. And they have a mean. So let's have a look here. Here I have two graphs, apples and oranges. And do whatever, the number of apples eaten by seniors in Calgary between 1987 and 1989. I don't know, whatever. Okay, so the number of apples eaten. So you have a look here. Your mean number of apples eaten is 68. And you'll see here, there's your first standard deviation, second and third. And on this side here, we have the negative first standard deviation, negative second, and negative. All right, but you see here. And you have a look here. What is the difference? What is your standard deviation here? Well, between 68 and 71, that is what? 9. And then 77 plus 9 is 86. 86 plus 9 is 90. So your standard deviation is 9 apples. Okay? And here's your graph. So lots of good information in here about apples. The average number is 68 and all these, and 68% of all data falls within here, 59 and 77 apples. Okay? And, okay, fine. Let's look at the number of oranges eaten. Okay, whatever the data says there, but we have a mean of 1,010 oranges eaten. And then you'll see here, within the first standard deviation, what's my difference here? 110 to 1,010 to 1,030. So here my standard deviation is 20. And then 20, again, there's my second standard deviation, and then my third is out here. So you see here, we've got different means. So how can I compare these? You really can't. I've got my standard deviation here, but my standard deviation here is from the mean is at 1,010, and it goes to 20 and 20 and 20. But here my standard deviation here, I'm at 68 and it's only 9. How do I compare these? And how do we do that? We need to standardize them. And it's going to look like this. It's going to look exactly the same. Okay? But now your mean is going to be 0. And I'll show you this. It's easy peasy. It's not too bad. There's a simple formula. Okay? And so what you do is you're transforming these. You see I have mean here is 68. You can, and I'm going to show you how to standardize this. So now, like here we were counting the number of apples, right? The standard deviation here was 9 apples eaten and another 9. Here, the standard deviation was 20 oranges eaten. Well, now what we're dealing with here is the mean is going to be 0. And now you've got 1 standard deviation, 2 standard deviation, 3 standard, which is kind of the same thing as what we've been dealing with right here. But now we're counting in standard deviations. And you're going to have negative on this side, positive on this side. I'll show you all this, okay? I'm just throwing stuff at the wall right now. Some of it will stick. And trust me, watch and see what will happen here. It'll be all good. So, what we're talking about here is we're going to be utilizing a formula in order to change these guys here using real apples or real orange numbers. We're going to use the Z formula to change them into this. So, and the formula is not bad at all. Z is equal to the value that you're looking for minus the mean, which I give you, all divided by the standard deviation, which I give you. So it's just a matter of plugging in numbers and playing right here. So this Z value, this is just another word for deviations away from the mean. Z value is equal to the number of standard deviations away from the mean. So let's have a look here. And the question here, I'm just trying to get the, come on, there we go. Move that out of it. So, completely fake example, but let's have a look at it here. It was determined that the average total time spent brushing our teeth was 1,010 hours over the course of our lives. Assume the standard deviation is 20 hours. Okay, so all right. What we have here now is, here is our graph. It just happens to look exactly the same graph as the orange is eaten. Yes. All right, so here's my graph. There is the average amount of hours utilized to brush our teeth. Standard deviation of 20 hours, 20 hours, 20 hours. And look, negative takes us down to 990. Another negative 20 takes us down to 970 and 950. Okay, fine and dandy. Whoopee-doo. Ian, what's that got to do with the price of eggs? All right, so what we're doing now is using a Z-score table provided to convert the following real data points into standard normal notation. So, where we're at right now is I've given you 3 points on here. Okay? And you'll notice there that they are not on the deviation lines. That was test 2. Keeping those points on the deviation lines. But here I've given you 3 points just out there. And the first point there is 1,041 hours. And you'll see there that 1,041 hours is right at, actually it should be right about here, right? There you go. It's right in there, right? 1030, 1050, 1041 falls in there. Another one here, the purple one, is 977 hours. Well, 977, probably right in there somewhere. There you go. And the last one there is 957 hours. And 957 hours. Now, again, the whole point of this is I want to compare apples and oranges. So what these 3 points here, what I'm asking you guys to do is you're going to input these into this formula. And a number is going to spit out, just like a computer program. Okay? So, and I've given you one example here. We'll do the yellow one here. So, I want to find the Z value for this point. So input it in there. There's my formula. Z is equal to the number minus the mean divided by the standard deviation. Well, I've given you all those. So I want to find the z-score for 1041. So z is equal to 1041, which is your value, minus your mean, which I've given you, divided by standard deviation, which I've given you, and you get a number there that's 1.55. Now what does that mean? 1.55, well, you have your same curve, but now we've standardized it. The mean is 0. Okay, you still have your same standard deviation bars there. They're still in the same spot as here. And where is 1.55? Well, there's your first standard deviation. There's your second standard deviation. 1.55 is right here. Well, funny, that's in the same spot as here. So they are identical. Okay, and that's what we're doing. I can't compare apples and oranges here, but once I do this, now I can compare apples and oranges. And if you do the same thing there with the purple, you get an answer of, I think, negative 1.65 right here. Okay, and that goes right here, which is exactly the same spot as here. And the 957, if I input it into this formula, I get a number there of negative 2.65, which goes negative 2, negative 3 right in here. If you get a negative number, it means it's on this side. If you get a positive number, it's on this side. And notice here that we were counting, I think we were counting the number of hours you take brushing your teeth here. Look how we're counting now. It's standardized, right? So we're still counting the number of hours brushing teeth, but what we've done is now we're counting in standard deviations away from the mean. So this point here is 1.55 standard deviations away from the mean in a positive sense. This one here is 1.65 in a negative, so negative 1.65 standard deviations away from the mean. Okay? And so that's all this question was asking you to do. There's a next step that we will take further, and you'll see there that in the week 11 folder, in the test 2 folder, all these, you'll see one of these guys here. And this is what we call a Z table. And for this question, I didn't ask for it. I was just asking for you guys just to practice putting those points on. Okay, big, if you guys can rock this out, you've got 90% of this, okay? And where we're going to be taking these Z values is you're going to be applying them against here. And I'll get into that. We're getting there. It's all foreshadowing. So again, to recap, very, very important skill. Okay? Give you a real value, input it into your Z-score formula, you will get a Z-score value. You can now input that onto a standardized normal curve. The point will be the same. But you see now we're able to compare apples and oranges now. I'll show you this. Where we're going now is I'm going to be asking you guys for the area under the curve. And the area under the curve is just a big long-winded way of saying probability. So where and what some of the questions I could ask you is, you see here, I could ask you there for the probability of choosing an apple from this area here, not this area, from here. So from this Z value lower. Now, getting back into this, you remember the whole area under the curve was 1. 100%, right? 100%. The whole area under the curve was 1. So going back to this one right here, look at this. We don't want this part, but we want everything lower than this Z value. So just offhand, look at this side right here. That's completely half of what we're looking for. What percentage do you think that we could just right now write on a piece of paper? You're right, 50%. So right there, that is worth 50%. Now you got to figure out this one. That is going to be somewhere maybe 35, 40%, somewhere in there. But I'll show you how to do that. Or I could ask you guys to find just this area. Now, how would you do that? Not too bad. Okay, we'll show you guys all these. I got lots of examples. Kind of the flip side there, I could ask you guys to find the area of anything to the right of a Z value. And again, this question right here, this one here, that's 50%. So you see how you're going to be doing these? I'll show you guys these right here. And even this one, right? Look at this one right here. I could give you two Z values. I could give you a Z value here and a Z value here and ask you to find the probability under here. Or here, or here. It's not too bad. So going back to utilizing where was it? It was this one right here. You see how we found the Z-score? I give you a real data point, you find a Z-score. Okay, what do you do with this Z-score now? You take that Z-score and you go into this table right here. Like what was that Z-score there? I think 1.55. That was it right here, right? That's for this point right here, 1.55. All right. How do we do that there? Well, the outside, this is where you look for your Z-score. So these are your Z-scores right here. So you find 1.55. There's 1, 1.1, 1.2, 1.5. Now, 1.55, you look up here, 0.1, 0.2, 0.3, 0.4, 0.5. So 1.55 is right here. So you see now, what you get now is a probability, 43.94%. But we write it 0.4394. So the whole point of this, you get a Z value, you find a probability. That's all this is. This one here could be probably one of the most important slides of the day. This Z-score table, okay, you find your probability, you find your Z-score, and then within it, there you find your probability, right? Well, how that table works is it works from the zero mean. So if I want to find a probability on this side, okay, this is how it measures out. If I want to find a probability on this side, this is how it measures out. And it probably doesn't mean a hill of beans here until I show you how it works, okay? But I will refer back to this slide again and again throughout today. Please remember that this is how the banana works, okay? Total area under the curve is 1, or 100%. This whole side here is 50%, 0.5. This whole side here is 50%, 0.5. So let's try one out here. Find the area, find the probability to the left of Z is equal to 1.99. So here, you don't have to use a Z-score. I already gave you the Z. I gave you the standard deviation value of Z.199, and it's positive. Okay, so you don't have to use your Z formula. Here, I'm only asking you guys to find the area under the curve. Now, you're looking at this, and I'm going to stress this as well. I will need you guys to predict an answer before you do it. And like what this question is asking you here is if I choose an apple from this distribution, what is the probability of choosing an apple from this area? So you look at this, man. There's one standard deviation. There's another. There could be another in there. So what are you looking at? You're looking at, well, which side do you know for sure already? Well, I don't know this side because I don't know what this area is in here exactly. But I do know this side here. So right then and there, off the bat, that side has to be 50%. It has to be because it's half. Okay? And because that's what we're talking about there. The whole thing. So right there, you've done half the question. Now, this area over here is the problem because I don't really know. So what you do is I've given you a Z value. You go into your Z table right here. 1.99 and it's positive, right? So there's 1.9. Apologies there if it looks a little skewed. And you go all the way over there to 1.99 and you get an answer of 0.4767. So 47.67%. So that's what goes here. And you see what that table tells you? And it's counting from here. Okay? So that 0.4767, 47%, is counting from here to here only. So choosing an apple from here will give you 47%. Choosing an apple from here will be 50%. You put them together there. Your total probability of choosing an apple from this area here is 97.67. Okay? That's how this one works. I got lots of examples. Let's try another one. Okay, here's another one. Find the probability to the right of z is equal to negative 0.116. So, again, this is what you would get on a test. I would just give you this and this. You may not even get this. Okay? What would you do if I didn't give you the graph? Well, you draw it. There's your mean, 0. Z is equal to negative 1. So this is 1.16 standard deviations away from the mean in a negative fashion. So it's right here. So we've got to figure out this area and we've got to figure out this area. Well, look at this. This area we already know. Easy peasy. Okay? Now, this area here we do not know, but I gave you the Z value. And you have a look. Now, we're looking for absolute, okay, the area under the curve, so we're not having any negatives, okay? The negative just means that it's to the left of the mean, okay? But we're looking for the positive values here. So 1.16, 1.1, sorry if you can't see that, I'll blow it up. 1.16. I've already done it for you. So 0.377. Okay. And again, you'll see that this table measures from the mean out. So that area right there is 37.7%. And that kind of makes sense because this is 1.16 deviations away from the mean. If it was 1 deviation from the mean, it'd be right here. What would that percentage be? Easy peasy, 34%, right? But it's a little beyond the first standard deviation, so it'll be a little bit more than the 34%, which is 37. But anyway, there we go. You add this guy up, you add this guy up, and you get a 87.7%. Okay, so that's how that one works. This one here, just a little bit of different notation here. Find the probability, okay, of z-score between 0, so that's your mean, and positive 2.32, right there. So we want to find all of this. We don't have to deal with this side. Just ignore it. We're only dealing with the probability of this space here. And remember that the z-table, it measures from here out. So we plug in our 2.32. Sorry, I'm kind of all over that. 2.32. So it's 0.4898. So 48% from here to here, and this one here is easy. We don't need to add anything up. It is what it is. The probability of choosing an apple from this area here is 0.4898. So that's how this one works there. I've got a sneeze and it's not coming. Come on. All right, good enough. And this one here, the last of these examples, is find the area under the curve. So find the probability, okay, from z is equal to positive 1.68 to z is equal to negative 1.37. So you see here we've got a z value here, we've got a z value here. All right. You remember that the z-table measures from the mean out. So you'll see here I have two z-table analysis because you'll need to measure from here to here, and then you'll need to measure from here to here, and you'll add these both together. And you'll see there that the z value for negative 1.37, you just do the positive. So 1.1, 1.2, 1.3, 1.37. So the left side of the table is 41.47. 41.47%. The right side of the table there is, what was that? Z is equal to 1.68. So 1.68, you got 45.35. So the probability for this side and the probability of this side total 86.82. Okay, that's how that one works. Try these out. You don't have to do them all. They become repetitious after a while. So have a look at these, practice these. So what I've showed you there is how to calculate a z-score. Okay, if I give you real apples, you can now change those real numbers into a standardized, where now you're counting with standard deviations using your z-score. In this questions here, I've given you the z-scores, and you asked you there for the probabilities. Okay, so you take your z-scores, you put them onto your z-table here, and you find your probabilities, and you can add up or do whatever you need to do to find your probabilities area under the curve. Okay, that's how these ones work. These are the same questions as we just did. It's just I didn't give you the curve and what it looks like. But you should be able to do it. And I've given you the questions here. I've given you some answers. Okay? So the probability of choosing of an event happening there between 0 and 2.16 standard deviations. Okay? So there's your curve. And there's your mean 0. So we're looking from 0 all the way out to positive 2.16. Okay. So 2.16, let's have a look at it. 2.1, sorry, I got to zoom up a bit here. 2.1, where's 6? Is this 6 up here? Yes, it is. This is the 6. So 2.16. Okay, is 0.4846. So 48%, and you'll see there 48%. So you should be able to do these without a curve. But do I recommend drawing a curve in the margin for your own peace of mind? Yeah. Good. So try these out. They're good ones. You will see them again. They're on the assignment too. This one here is opposite. Here I've given you the probability, the area under the curve, and I'm asking you to find the z-score. Well, you'll see here by the arrows, what are you doing? You're just working backwards. So if your area here is 0.2123, you just go through the entire table and you find 0.2123 or closest to it. And then you just work backwards. So it'll be 0.56. So my z value is 0.56. Okay, which is right here. So here you're just working backwards. Not too bad. What else we got? Here's some more. Okay, where I give you the I give you the area under the curve. I give you the probability. Find me the z-scores. That's it. And you got the answers there. You got the questions. You're good to go. Now, welcome to the application. Here, we're going to give you real life examples, and you're going to transform it all, and you're going to make some magic. These are good. These are kind of fun, and it's just a puzzle. Try these out, practice them a couple times. You'll see the exact same thing on the test. I'm just going to change the numbers and the scenario. A survey by the National Retail Federation found that women spend on average $146.21 during the holidays. Obviously, my wife was not involved in this study. There you go. Assume the standard deviation is 29.44. So you look at this. Average spent during the holidays. There's your mean. I didn't say it, but you'll have to pick that up. Okay? Assume the standard deviation is $29.44. All right? And the question is asking you, find the percentage of women who spend less than $160. So, you may or may not get this, but it's easy enough to draw. Okay, you draw your Gaussian curve. Okay, and you could actually put in your mean is $146.21. Your standard deviation is $29.44. So you see, you have your, if you're unsure about how to, you can practice these a couple times here. So there's your first, you have your mean plus $29.44 will give you your first standard deviation. And then if you wanted to add another $29.44, that'll give you your second. Just kind of gives you a picture of what's happening here. And you know what I mean? It doesn't have to be pretty. You just have to be able to understand it. So here's your curve. There are your standard deviations. There are your numbers for your standard deviations. But the question is asking, find the percentage of women who spent less than $160. So $160 is somewhere in between 146 and 175. Yeah, we'll just put a line right there. So we want everybody less. We want to know how much. Well, let's have a look here. What can we say? What do you, and this all goes back to guessing. How much is this? What's the percentage on this side? 50%. So that's already done. That's 0.5. The problem is this. I don't know this. But you see how it falls in between the first standard deviation in here would be 34%. So what do you say? This is somewhere maybe around 20%. I really want you guys to try and practice this. Is it necessary to get the right answer? No. But being able to predict your answer will eliminate calculator error. So you see here, this is 50%. This is about 20, 25%. So we're looking for somewhere around 70%. That's the number we're kind of looking for. Okay. All right. So, same question. Let's go. So we want to find the percentage of women who spent less than $160. Use your Z formula. $160 minus 146.21. That was your mean given. And divided by your standard deviation, we got 0.47. Well, what do? That's your Z value for this $160. So 0.47, 0.47. So that means that this area right here is 1.808. Okay, that's the probability of choosing somebody from this area, because remember, your table counts from here out, the mean out. We already know that this is 50%, so you add this and this, we get 68.08, all right, which is 0.6808, which is 68%. Is that an acceptable answer? Yeah, that's in and around the 70% we were looking for. Okay, so here in this case, you took real numbers, and you see here, here's your real graph, your real number mean, $146, your standard deviation, each going up by 29.44, 29.44, 29.44, 29, and what you did was you change this there to a standardized normal distribution by utilizing a Z value. And when you do that, you are able to find the percentages. And the percentages there, just another word there for probability. Good. Let's do another one, shall we? So each month an American household generates on average of 28 pounds of newspaper. Boy, that's I never thought about it. Each month an American household generates on average 28 pounds of newspaper. That's basically a pound a day of newspaper. What are they reading down there? Assume the standard deviation is 2 pounds. So there we've got an average of 28 pounds, which is the mean, and we've got a standard deviation of 2 pounds. If a household is selected at random, find the probability of it generating between 27 and 31 pounds per month. Assume the variable is approximately normally distributed. Okay, so doesn't make any sense? It's okay. Draws a graph. So here we've got a graph here, and you draw it up, and you put in your standard deviations if you want. 34%, 34%. Doesn't have to be perfect. Okay, and there's my 95% range, and then here's my 99.7. First, second, third standard deviation. Okay, so my mean was 28. Bang, goes right in the middle. And we want to know what's going on here as far as 27 and 31. So you put in your 27. Okay, there you go. And 27 and 31. These are my numbers here. So what are we looking at here? Somewhere around, I don't know, 30, 40, 50%. So just have that number in mind there. Okay, because that's the number we're going to be looking for. So now I've given you 2 points here. What are you going to have to do? You're going to have to do 2 Z values, because I'm asking you to find the area under the curve between this Z and this Z. Okay, so what do? Here we've got, you find the Z value there for the 27, and you get a number there of negative 0.5. You look up 0.5, you get 0.1915 right there. So you remember there that this measures from the mean out, so that's 19%. And then you do the other Z value for 31. 31 minus the mean divided by 2 gives you 1.5. You'll see there 1.5 is 0.4332. You add these two guys up, and look at that, 62%, and that was around where we were looking. So it makes sense. Okay. The last example is the same thing. It's just adding an extra one little step. The American Automobile Association reports that the average time to respond to an emergency call is 25 minutes. That's your mean. Assume the variable is approximately normally distributed and the standard deviation is 4.5 minutes. If 80 calls are randomly selected, remember these guys here? These guys here, I was only choosing one. This is the extra step here. Is it difficult? No. If 80 calls are randomly selected, approximately how many will be responded to in less than 15 minutes? So there's lots of things going on here. Pull things out, get rid of the language, pull things out there. Your mean, 25 minutes. Standard deviation, 4.5 minutes. 80 calls, less than 15 minutes. That's all you need there for this guy. Okay, so draw your curve. There's your mean at 25. Okay, you could put in your standard deviations there. Okay, 4.5 minutes, so that would be 29.5. That would be 34, 38.5, these kinds of things, right? But this is what we're looking at. 80 calls responded to in less than 15 minutes. So we're only looking for this amount. So where are we at? 10%, 7%? We're looking for a pretty small number. Okay. So what we do is we input our 15. Now, please pay attention to this one. I'm looking for the area under the curve for here. But you will remember that your z-table only counts from the mean out. So if I input, I'm looking for 15, right? I input that in my 15 minus the mean divided by the standard deviation, gives us a number of negative 2.22. All right, I'm going to go to my z-table and 2.22. 2.22. So I get a number of 4868. So be careful. You're going to get a number of 4868. So really the possibility or probability of choosing a person from here is going to be 48%. That's almost 50%. That's almost half. Doesn't make sense. So remember that the z-table measures from the mean out. We don't want this area. We want this area. So what we have to do is we have to subtract 0.5, because that's the total area here, minus this gives us an answer of 0.0132, which is 1.32%, which is very small, which now correlates to our original guess of a small answer. I'll do that all again. You remember this slide up here? Very important slide. You remember these z-tables, they measure from here out. Well, if you look at this example, the last slide, I want to know this area. Okay, so I find my z value, which we found, which is 2.22, negative 2.22, because it's on the left side. You find it in there, 2.22, we get a probability, a percentage of 48.68%. Well, that doesn't make any sense, because this is a very small value. This is negative 2 point, this is outside the second deviation. So you have deviation 1, 34%, deviation 2, this one falls outside. So in order for it to make sense, we take the whole area, minus that from this area, because the z-table measures from here out, and what we get left over is this area. Okay, so if I was going to choose one person from this group that would get a call there between, or receive assistance with less than 15 minutes, it would be a 1.32%. But now, you see, I have 80 people that I've thrown into the mix. All you do is you take this number and you multiply it by 80. Okay, and what you actually get is a real world example that out of 80 people, 1.056 calls will be answered less than 15 minutes. So have a look at these. I know but what I need the most important slide is this understanding, this whole idea of how this works. Okay, I'll give you a real world example. Okay, all right, I'll give you the mean, I'll give you the standard deviation, and I'll give you the parameters of what I'm looking for. You'll have to change these guys to z values, find the probabilities, find the area under the curve. I may give you the z values and only ask you to find the probabilities. I may give you the probabilities and reverse it, ask you to find the z values. So this is where we're at right now, okay? That's all the information there that will be on quiz 3 next week and test 3, okay? Basically, all we're looking at is stuff that was covered from last week and this week. But please, I will go after figuring out variance and standard deviation in a table. Okay, so that's pretty much the only carryover from previous units. Okay, so variance, standard deviation, being able to calculate that. Okay, probability and odds there from last week, and here we have this week's stuff here. Okay, yeah. So I don't even know if anyone's still there. Oh, I see. Yes, very good. And don't go anywhere because I'm going to go over the assignment 2 and just make sure y'all are doing all right on that. Okay? So, any issues with this stuff, get a hold of me. The reason why we do, normally I have 2 weeks of review because it's a 14-week semester, right? But we've lost a week there, but you guys will be just fine. Don't let this stuff slide. Take a day, get it, and once you get it, it's pretty cake. Okay? But try it a couple times. And if you're not getting an answer twice, you do it twice and do not do it a third time. Email me. Instead of doing it a third time, email me and say, Ian, question number 4 is irritating me. I can't get it. It could be a wrong answer. It could be you're just doing something not right. But whatever it is, we'll get it squared up. Your time is more valuable than mine. Okay? You guys are the customers. You guys are here wanting to better yourself. So use me. Email me. Bother me. Hassle me. And check your marks too. If you see something funny, if you got a 0 and you know you did it, email me. Tell me where you sent it or uploaded it, and we'll get those marks to you. I've got a couple cases on the go right now. Okay? It's just normal for doing a VR class. Okay? But please be vigilant on your marks. Okay? The assignment. Okay? So, and again, I apologize there for changing the format. I was going to give you guys another paper test where you guys do it, show me the work, take your pictures, upload it, but I just thought I'd try something new, and if I could save some trees while I'm at it, then let's do it. Okay, and ultimately, if I save 10 pieces of paper, then I've done my job. I apologize if I put anybody out. I think I've actually kind of made it a little easier there for you guys, which is all right. But you need to understand, there are no more part marks. This will be uploaded there to Blackboard. You'll input your correct answer, and that will be it. Okay, so please make sure your answers are spot on. Just to go through this here, suppose you draw, there has been some issues. Some people have told me there that they don't really understand cards. You'll have to some extent. In the week 10 PowerPoint, I gave the parameters there of a card. There's 52 cards in a deck. There's 4 suits, diamonds, hearts, spades, clubs. Okay, the cards go from 2 to 10, Jack, Queen, King, Ace. Okay, I will be utilizing a couple of those questions there for the quiz and the assignment here on the test. So if there's any issues with that, email me. We'll do a WebEx and we'll get you going on cards, okay? So what is the probability of drawing a spade? And you'll see here that each of these has how I would like it answered. I think there's 1 or 2 of them there that I've changed, okay, from the original test. So this is the one you're looking for here, and this is the one here that will be replicated, or this is what it will look like there on Blackboard when you enter your answers into the e-portal, okay? What is the probability of drawing a red even numbered card? What is the probability of drawing a king or an ace? Okay, so these are the ones here were cards, only cards. Here, question 2 is only about marbles. Suppose you select without looking 2 marbles from a bag containing 4 red marbles and I think 10 green marbles. Yeah. Okay. What is the probability of selecting a green marble first and then a red marble with replacement? There's keywords all through these, or, and then. Y'all got to pick them out. Okay. And answer is the lowest fraction. So 2A and 2B, these have to do with marbles. Question 3 has nothing to do with marbles. This is a whole different question. Okay, has nothing to do with marbles or cards or anything. It's just what are the odds of an event occurring if the probability is 5 over 12. There is a relationship between odds and probability. Find it. Okay, and please answer in ratio form. What are the odds of rolling a sum of 7 with 2 6-sided dice? Good question. If the odds are 15 over 20, what is the probability? Okay. What are the odds of drawing? Now this one here. What are the odds? Now what's your formula there for probability? The number of desired divided by the total. What's your formula for odds? The number of desired divided by undesired. They're different, but they're definitely related. So here, what are the odds of drawing a 10 card from a deck? And then the odds of rolling a 4 with a 6-sided dice. And then getting ahead on the flip of a coin. And then. 7. Good one. These ones here, I like this. Apologies, it's not nicely worded, and that's just the way it is. At a used book sale, 90 books are math books and 130 are science books. Of the math books, 35 are statistic, while 60 of the science books are geology orientated. Ugh. Too bad though. It is what it is. And you fill out this chart here. You'll need to fill this chart out in its entirety before you attempt these. Okay? And it's in there. You just got to dig around. So you got that one there. B, C, D. Okay. For all remaining questions, you'll need a Z table. So that table there, this one here. Okay? And so to the right of 0.23, to the left of negative 1.43. Same stuff we've just done. Okay? And then we've got some real life questions there like we did there at the end of today's PowerPoint. And that's it right there. So I'm going to stop sharing. It doesn't mean I'm going to stop sharing. I'm just going to stop screen sharing. But that is where we're at. I'm going to stop